Good evening to Attorney Ceballos and to the Property and Land Law class. I am Engineer Arbasto, and today I'll be talking about the easement of building drainage and the drainage system design. In engineering and construction, when we say easements or setbacks, these are allowances established to allow for the installation, access, operation, and maintenance of infrastructure which are critical in managing water flow, waste, and sanitation. And of course, these setbacks should be in compliance with local ordinances and national laws like the National Building Code, Plumbing Code, Sanitation Code, and other environmental laws. So there are different types of building drainage system, but I'll be talking about those that are relevant for easement laws. First, under the wastewater drainage system, we have the sewer system. So sewer lines are underground pipes that carries wastewater and human waste away from buildings and to a designated disposal. According to the National Plumbing Code of the Philippines, no building sewer or other drainage pipings or part thereof shall be installed under or within 0.6 meters of any building or structure, nor less than 0.3 meters below the ground surface. The primary reason for this is to protect the structural stability of the buildings and also to ensure proper waste management and drainage. And most importantly, this easement is to safeguard the environment and public health. However, exceptions may be considered with the right approval from the right authorities. So in certain instances, where the land has specific zoning or land use designations, the local building official, which approves the plumbing permit, may allow a reduction of this setback distance. So this would require the submission of technical studies such as site analysis or drainage impact assessment to ensure that safety standards and functionality are maintained despite the exception. Another instance is under local ordinances. So some local government units may have additional requirements for sewer line setbacks depending on the local context. For example, if the land is located in a flood-prone area, there are special provisions for that. And also if there are urban planning regulations in place. And lastly, for shared sewer systems, so in areas where properties are connected to a shared sewer system or there is a communal septic tank, the required setback might be adjusted to account for the centralized location of waste disposal infrastructure. However, even in shared systems, it is important to note that sufficient space must be provided for maintenance and repairs of the lines. The second part of the wastewater drainage system is the septic system. So a septic system is a private wastewater treatment and disposal system. It is designed to handle the treatment of wastewater from households or small businesses. This is very common in the Philippines since we do not have wastewater plants, and so a septic system is used to handle this wastewater. Over 85% of the population depends on private septic tanks, and one of the largest public septic system is located in Metro Manila. But out of its entire population, this public septic system only caters to 20 to 25% of its population. So the system typically consists of several components that work together to treat and safely dispose of wastewater from toilets, sinks, showers, and other household drains. Considering that the septic system deals with wastewater treatment, there are setback distances in place for it. So from water sources, septic tanks must be located at least 25 meters away from any existing source of drinking water such as wells or cisterns. So from buildings, septic tanks shall be constructed at least 1.5 meters away. Same from property boundary, there should be a setback distance of 1.5 meters away from any property line. I placed an asterisk on this part because the 1.5 meter offset is actually just a rule of thumb in the construction industry, because this distance allows for maintenance and ensures structural stability of the buildings. And lastly, in flood-prone areas, septic tanks should not be located in areas prone to flooding to prevent overflow and environmental contamination. Next is the stormwater system. So this system deals with the disposal or drainage of rainwater. So specific design requirements are in place. Roofs must have gutters, downspouts, and piping systems properly designed to channel rainwater. And these storm drainage systems must be integrated to connect to a city drainage or soak-away pits, ensuring no runoff into neighboring wells. However, here in the Philippines, we commonly find roofs without gutters that directly discharge rainwater to the ground. No specific easements are provided for these cases. However, a general principle is adopted for property owners. Rainwater must be collected and disposed of in a manner that preserves the integrity of neighboring properties and public spaces. Similar with the principle on the previous side, in managing the drainage discharge points, the property owners, engineers, or architects should make sure that water should discharge onto either public drainage systems, properly designed infiltration systems, public streets when allowed, and that it should not discharge onto private neighboring lots or pathways where it can create hazards. So aside from building drainage systems, there are also other drainage easements observed during construction. First is the natural drainage easement. So basically it states that water flows naturally between lots. So therefore, lower estates will receive natural water drainage from higher estates. These lower lots should be designed to handle the incoming flow of water, while the higher lots shall ensure that there is no obstruction or redirection of the natural water that may cause damage on the lower lot. In cases where the property is located near artificial drainage systems like public canals, building of structures, fences, or encroachments may be prohibited within a setback zone, often around 3 to 5 meters depending on the local government unit. And since water is naturally designed to run off to rivers, streams, seas, and lakes, there are also easements in place for this. So for any natural bodies of water located in urban areas, there is a 3-meter easement zone. For those that are located in agricultural land, there is a 20-meter easement zone. And for forested zones along creeks and rivers, there is a 40-meter easement zone. Local governments may enforce stricter easement rules under the Local Government Code, and also it is important to note that permanent constructions within these zones are banned, and violations to this law may impose fines or may risk demolitions of their buildings. Another easement observed in construction is the road right-of-way. So this is the total land area acquired and reserved for the construction, operation, and maintenance of the road. So in the Philippines, road right-of-way width requirements are governed by the DPWH, and they vary depending on the road classification and function. So for primary roads like national highways that link cities, the road right-of-way width is typically 30 to 60 meters, depending on the determined alignment, the traffic studies, and safety considerations for that road section. For secondary roads that link inner cities to the primary road, the ROW width is around 20 to 30 meters. And for other roads that are governed by the local government units, they still follow the DPWH or DILG-DPWH Joint Memorandum Circulars. So for provincial roads, that is a 15 to 20 meters right-of-way width. For municipal roads, that is 10 to 15 meters. And for barangay roads, that is 6 to 10 meters. So the provision of this road right-of-way ensures that adequate space is reserved not only for the current roadway, but also for future expansions, utility installations, pedestrian paths, drainage system, and road safety features. So it's not just about physical dimensions, it can also be for the sustainable and resilient infrastructure development. In conclusion, the establishment of proper building drainage easements is not just for design consideration, it is a critical legal and engineering requirement. So these easements ensure that Drainage systems can be accessed, maintained, and operated without the risk to surrounding properties or public infrastructure. So easements also help prevent hazards such as flooding, contamination, and structural damage. Compliance with codes and regulations ensures that drainage systems not only serve their purpose but also protect public health and environment. By respecting and implementing these legal boundaries and design standards, we engineers contribute to a responsible urban and rural development. And that is all on easement of building drainage and other easements observed in the engineering industry. Again, I am Engineer Arbasta. Thank you for your time.